Welcome to 7.5, Solving Rational Equations. So this is the last section in the chapter. And as a reminder, feel free to pause this video anytime that you need to and make sure that you are getting all of the notes down. So I keep saying this throughout this chapter, and that is the fact that I truly love this because they are all skills that we've done before. We're just kind of stepping up our game, and especially with solving these. So we're going to be using two things that we've already learned before. So first one that I want to start off with is actually something that you have seen all the way back, maybe in 6th or 7th grade. And that's a ratio. Rational equations, ratio, first part of the word. And we're going to be using a method for this one that we call cross multiplying. Cross multiplying. So what we're going to do, and you guys have all done this before, is that we're going to take our two terms over here and we're going to multiply them together. So we have 2 times 9. And then we're going to set that equal to our other two terms that we're multiplying over here, 5 times x. And it works out because you are able to, it's basically multiplying both sides by 9x. Because you're multiplying by your denominators. So this one ends up being 18 is equal to 5x. Divide both sides by 5. 18 over 5 is equal to x. So that actually is solving a rational equation. But because it's algebra 2, we want to step it up a little bit. We're going to start looking at a little bit more difficult ones. So let's start with example 1. In example 1, we have -4 over x plus 3. We're going to set that equal to 5 over x minus 3. Now, still the same technique here. So we're just going to go ahead and we are going to cross multiply. So I'm going to take this -4 and I'm going to multiply it by the x minus 3. And then I'm going to set that equal to our other side. And we're going to multiply our 5 times x plus 3. And it's a basic linear equation we can solve from here. -4x plus 12 is equal to 5x plus 15. I'm going to do 2 steps in one here. I'm going to subtract 5x from both sides, but then I'm also going to subtract 12 from both sides, meaning that 9x is equal to 3. Divide both sides by -9. X is equal to a -1/3. All right, so again, being able to cross multiply does depend on the fact that you have one rational equation, one rational expression on both sides of the rational equation. But you're definitely able to use cross multiplying as a method with solving these. Now, I'm going to show you one other method, and you've been doing it for a while, so this is going to be example 2. And I'm setting up my equation first. So I'm going to set up the equation. I'm going to leave a little room to write. So if you want to skip a line, that's a good idea. 3x over x plus 1 minus 5 over 2x is equal to 3 over 2x. Okay, so what I could do here is that I could go ahead and use the techniques that I've done before and combine those two equations, then use cross multiplying. However, there's something that is even better. And we have done this before when our denominators are numbers, but now we're going to do it when our denominators have variables. And that is that we are going to fraction bust. So I'm just going to go ahead, I'm going to put a star over here, fraction bust. And remember, when we're fraction busting, we're using our least common denominator for our terms here. So I'm going to multiply everything by 2x times x plus 1. And as we can see here is that we have a 2x here and a 2x here. That's going to end up canceling out with our 2x up there. But we also have an x plus 1 down here, which is going to end up canceling up there. So every single term here I'm multiplying by 2x plus 1. So I'm going to go ahead and I'm going to distribute this to our first term. And what's going to end up happening is that the x plus 1 is going to cancel out, however the 2x stays. So I end up with 6x squared because 3x times 2x is 6x squared. All right, and then I'm going to go ahead, I'm going to take my 2x times x plus 1, multiply it by my second term, and we end up canceling out the 2x, meaning that I'm left with a 5 times x plus 1. And then we're going to set that equal to, I have one more term that I need to multiply here, and that's my last term over here. And the 2x's cancel out, but you still have that x plus 1. So we're left with 3 times x plus 1. Now from here, I have a quadratic equation. I need to distribute and set equal to 0. So I have 6x squared minus 5x minus 5 is equal to 3x plus 3. I'm going to move these over to the other side and set this equal to 0. So we have 6x squared minus 8x minus 8 is equal to 0. I definitely want to factor out that GCF of 2. Excuse me, I need to write 3. 3x squared minus 4x minus 4. And once again, we definitely can factor this one. If you need to use the generic rectangle, that's totally fine. However, I am going to challenge you to try to factor a little bit quicker. And you can do this by thinking about the terms that are going to multiply to 12, negative 12, so that's 3 times negative 4, but add up to a negative 4. And that ends up with my 3x plus 2, so negative 6x, and then add 2 to get to negative 4x. All right, so when I'm solving this, I'm going to actually switch colors here, because when I solve this, I know that 2 definitely can't equal 0, but I can set my 3x plus 2 and my x plus 2 equal to 0. So 3x plus 2 equals 0, and x minus 2 equals 0. Solve from here, meaning that x is equal to negative 2 over 3, and x is equal to 2. Now, it's always a really good idea to go back and check your work. I'm going to add a star here. Check work. But in terms of time right now, I'm going to let you know that both of these equations, or both these answers work, and we are good to go. We can even go ahead and box them. So this guy and this guy. Okay, so we're at that time. I'm going to switch colors here. Put it in green today, and what I'm going to ask is that you try 15 over x plus 4 over 5 is equal to 7 over x. Go ahead, hit pause, do your own work, and come on back. Okay, so I'm going to multiply this by 5x because that's my lowest common denominator. And when I multiply it by my first term here, the x's cancel out, so I have 15 times 5, that's 75, plus 5x times 4 over 5. Now the 5's cancel out, so I'm left with 4 times x is equal to, my very last one here, the x's cancel out, 35. All right, that's a linear equation. I got this. I'm going to subtract 75 from both sides, meaning that 4x is equal to negative 40. Divide by 4, and x is equal to negative 10. I'm going to go ahead, box my final answer. Very nice job. All right, so there are some times that we need to really double check our answer, and it's our favorite thing. It's that extraneous solutions. So I'm going to say check for extraneous. And we're going to use example 3 here. Now, extraneous solutions are really tricky, especially when those x squared start popping up. So on this example, I'm going to skip a line for some room, 9 over x minus 2 plus 6x over x plus 2 is equal to 9x squared over x squared minus 4. Now, before we start this one, it's always a good idea to check to see if any of your denominators can be factored. And hopefully you saw down here that this one actually is a ding-dong, or a difference of squares, and it can be factored into x minus 2, x plus 2, which is super handy when we are going ahead and fraction busting, because now my lowest common denominator is simply just x plus 2 times x minus 2. And so I can now multiply these out, and they're going to start canceling out with our denominators on this one. So let's go ahead, let's multiply it by our first term. So we have this guy over here. Now the x minus 2's are going to cancel out, but we're still left with 9 times x plus 2. Next term, plus 6x times, the x plus 2's cancel out, but x minus 2 is still involved. Now for this last one, they both end up canceling out, so we're just left with 9x squared. Okay, let's go ahead, let's distribute, see what kind of equation we have. So 9x plus 18 plus 6x squared minus 12x is equal to 9x squared. All right, definitely a quadratic. We need to start setting equal to 0. I'm actually going to do this with some colors so that you can see every step. I always like to keep my leading coefficient positive if I can. So I am going to do that by moving everything to the right side of the equation. I just used my x's in darker purple. We'll use this kind of teal here, and then minus 18, minus 18. Okay, so I know that everything on the left side of my equation is going to go ahead, and that's going to cancel out to 0. That's why I moved everything over. Now I need to really focus on I'm going to highlight here, this side of my equation and combining some like terms on this side. So we have 3x squared. Negative 9x plus 12x gives me a positive 3x, and then a negative 18. Now this looks a lot more easy to handle. I'm going to factor out a GCF. Ooh, this one ends up factoring lovely. We have x plus 3 and x minus 2. Set everything equal to 0 that you can. Sorry, the screen keeps moving. So I know that this guy and this guy can set equal to 0. And 0 is equal to x minus 2. Solve. We have negative 3 is equal to x, and 2 is equal to x. Okay, so I need to go ahead and I need to check some answers. And this is what I'm noticing right away, is the fact that if I have an x is equal to 2, but I go back to my original equation and I either plug in 2 here or I plug in 2 here, I'm going to end up with a problem. So I know automatically that I cannot use this, that it is extraneous. However, I do know that when I plug in negative 3, that's going to work. All right, congratulations, you are through your notes.